Okie dokie. Today we're going to do the board overhang problem where you hang boards over a table and figure out, not derive it, but just state the formulas to figure out how to balance books or boards off a table so that they can actually overhang the table. Let's start with this formula right here, which tells you how much to overhang the very first board on here's the table, here's the first board. We'll have like n boards, so we'll try it for 4 boards and then 3 boards and see how much to hang it over. The formula to know how to hang over going from, this is going from bottom up. This is bottom up, bottom up, and later on we'll do top down here, which is a lot easier formula to do. But bottom up, to know this board, the first board that touches the table, you have to overhang it the length of all the boards. We're going to have the exact same length, of course. So the length of the board divided by 2 and divided by the number of boards you have minus 0. That will be the first one. The second one will be the length of the board over 2 parentheses n minus 1, and it'll go on to n minus 2, to n minus 3, and so on until you get to the last board. The last board will be, since we start at 0, if you have 8 boards, this number has to go 0 through 7, so the last board will be 2 times parentheses n minus 1, close parentheses, close parentheses. So again, if you had 8 boards, you're going from 0 to 7. It will give you all the lengths of the 8 boards. It turns out that the very top board will always overhang L over 2. So let's just quickly do this for 4 boards. If you stick in a 4 into here, you'll get 2 times 4, so it's L over 8. So this first one has to hang over L, the length of the board divided by 8. That's this overhang distance right here. If you stick in, that's sticking in 4. Sticking in 4 into here, 4 minus 1 is 3. 3 times 2 is 6, so it's L over 6. So we get L over 6, and so on. You can do it. It'll give you L over 4 and L over 2. We had 4 boards. So these are our 4 distances. So this distance right here, if you have 4 boards that are all the same length, and it doesn't matter, the length doesn't matter, this board will overhang by the length of the board divided by 8. This distance from here to here, the overhang distance, that's this distance right here, that it overhangs this board, is going to be L over 6. This distance right here, the overhang of this board relative to this board, is going to be L over 4. And then the last one always is going to be L over 2. Of course, if you do this because of imperfections, we suggest you do a little bit less than these values, just to be on the safe side, because this is the unstable engineering point of the situation. Just quickly do it for 3. If you had 3 boards instead of 4 boards, stick in a 3. I'm doing another one just to show you the pattern that I get this formula for. Notice that if you stick in a 3, you get 2 times 3 minus 0, 3, 6, L over 6, L over 6. Stick in 3, 3 minus 1 is 2, 2 times 2 is 4, L over 4. So you get L over 4. The last one will be, of course, L over 2. There's your 3 boards with the overhang. So if you have 3 boards, this distance will be L over 6. This will be L over 4, the distance from here to here. The distance from here to here will be L over 2 if you have just 3 boards. And the reason I did these two is just to show you that it's always the exact same pattern. It's the length of the board divided by 2, 4, 6. 2, 4, 6, 8. 4 boards, 2, 4, 6, 8. 3 boards, 2, 4, 6, 2, 4, 6, there's 3 boards, 18 boards, 2, 4, 6, 8, 10, and so on. And so the formula we can see really quickly if we go what's called from top down instead of from bottom up. This lists how to overhang from this board to that board. So this is the bottom board, this is the top board. This formula is a lot easier to memorize, and it's called the top-down formula. What it says is, don't worry about the table for now. Just get your first board, and if you have 4 or 3 boards, let's just do 3 boards just to to just make it easy. If you have 3 boards, stick in, of course, 1. You're not going to stick in 0, otherwise you'll get infinity. So this formula already denotes that n will start at 1 here, whereas opposed to, yeah. So n will go from 1 dot 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 to 1, 2, 3 to n. So that's kind of neat also, because this formula goes from, if you have 8 boards, 0 to 7, but if you have 8 boards here, it'll go from 1 to 8. So it's kind of a neat formula. But it is what's called the top-down formula, and that is that you stick in 1 for the first one, it's L over 2. That's this distance right here of the top board. Then stick in 2, L over 4. That's this distance right here for the next board underneath the top board, and so on. And so what they say is construct this from top down, and don't worry about the table. Then once you've constructed that, set that on the table, and of course you'll know what this is, because when you stick in the last one, like for suppose it's 1, 2, 3, the last one will be 3, L over 6. So you'll note that this last one will be this distance right here will be L over 6. So put the whole contraption on the table. Sometimes that's a little bit difficult to do, so doing the top down or the bottom up. But either way, you can calculate those values for the thing. So this way it's but it's just, we got to remember that this is the top down formula, and this is the bottom up formula. So again, for n equals 3, we get stick in 1 L over 2, stick in 2 L over 4, and stick in 3 L over 6. Okay, and so of course those are the exact same values you got here, but they just went backwards, because this will be the top board, this will be the bottom, the next board, and this will be the bottom board. Whereas this is the bottom board, the top board, and the bottom board, the next board, and the top board here. Okay. Oh, this went a lot longer than I wanted it to. All right. Well, I hope you enjoyed the video, and I look forward to any comments at the bottom. Thank you very much.